Magandang umaga po sa inyong lahat, mga kabayan.
Good morning, everyone. We are now on Lesson 6, Algebra Word Expressions. Last time we had Lesson 5, solving equations using formulas.
Here in Lesson 6,
You'll learn how to translate word expressions into numerical and algebraic expressions.
you may not believe it, but
Real-life situations can be turned into algebra. In fact, many real-life situations that involve numbers are really algebra problems. Let's say you went out
to a Safeway store and bought some groceries.
and you spent like say 42.50 and you were given a change of $23. How much did you tender the cashier for your payment? And since you forgot how much money you gave the cashier in the first place, now you need to know, you have to figure that out. Now with the use of algebra you can figure that out. Okay, so let's put that into numbers or
Numerical expression. That's $22, your change given back to you by the cashier.
so the amount of grocery that you bought for is 42.50. So the cost of your groceries, cost of trying to figure out how much money you gave the cashier. So that represents as let x the unknown that you give the cashier. So tendered amount. Now since you know your change, you were given a change because that's what you saw. You give to you $23 and the cost of your groceries 42.50. So how do you figure that out? So x is the total amount that you gave. You were given a change. So x is equal to, how do you translate that into equation? That's your total money given to the cashier, and you're given a change $23. So that is $23 plus your 42.50. That's the amount of your groceries. So that's x, right? That's easy, right? Add that up. So how much money you got? 23 plus 42.50, 65.50. So that's 65.50. That's the value of x. That's the amount of money you gave the cashier.
You gave 50, 10, and $5 bills and
some coins, 50 cents. That's how to translate that one right there, right? That's real life application of algebra, right? And now, how do we turn words into algebraic expressions? So algebraic expressions is different from numerical expressions, but they're alike. And so numerical deals with numbers, and algebraic expressions we deal with variables. Simple as that. But how do we turn words into algebraic expressions? So let's describe, say in words like 2 less than 5. How do you illustrate that in the form of numerical expression? 2 less than 5, that's how it is represented. Now we have another word or phrase, 5 reduced by 2. That's the same way, right? 5 reduced by 2. So, or 5, what's the other one? Decreased by 2, right? That's the same way. So there are many ways how to express that in words. But when you translate that into algebra or numerical expression, it will be a little tricky. And the other way to express that one also is the difference between 5 and 2, right? The difference between 5 and 2. If you write it down, it cannot be 2 minus 5, right? There's no way you can do that, right? It's like common sense that since we know 5 is bigger than 2, so that should be 5 minus 2, right? It's like the difference between 7 and 8. So you cannot write that down 7 minus 8, right? It should be 8 minus 7. That's what it means. Should be 8 minus 7. Now let's start with writing basic phrases. What does it mean by basic phrases? Operation signals, we call that one, like let's say less than. That's a basic phrases to introduce or signal operation that needs to be taken in simplifying expressions. Less than or greater than, and some a lot more, like fewer or fewer than, or 5 fewer than 8, things like that. And in some cases, when you see parentheses, let's say like you're subtracting or multiplying things, numerical values like 2 plus let's say 7 divided by 2, or let's say 2 times 7 plus 2. You see that the parenthesis signals you have to do the operation first in that parenthesis. So how do you say that in words? Basic phrases. 2 more than 7 multiplied by 2, or say 2 multiplied by 2 more than 7, or 2 times the quantity 2 added to 7. Different ways to express that kind of mathematical operation. Let's say on this phrase right here, so less than, let's say 5 less than 7. How would you write that one right there? 5 less than 7. So that's 7 minus 5. Right? How about this? Greater than. 2 greater than 6. How would you write that down? That's signals addition, right? So 2 greater than 6. So 2 greater than 6. That means addition. So those phrases signals the operation, mathematical operation that we have to do to simplify the numerical expression. How about the sum of, let's say, the sum of 3 and 4. How would you write that down? The sum means or signals addition also. Sum, so the sum of 3 and 4. So sum of 3 plus 4. Right? The same way as the total. The total of 3 and 4, the same thing. And so that signals addition. How about the difference? The difference signals subtraction, right? Say the difference between 6 and 3. How would you write that down? Is that 3 minus 6 or 6 minus 3? It's 6 minus 3, right? So the difference between 6 and 3. So 6 minus 3. Yeah. How about the quotient of 8 and 2? Whenever you see quotient, that signals what? Division, multiplication, or what? So that signals division. So let's say the quotient of 8 and 2. So how would you write that down? So 8, is that 8 divided by 2 or 2 divided by 8? Whenever, whichever is the letter that's mentioned first should be indicated as the numerator. What I mean by that is that's the one staying on top. Like, say the quotient of 8 and 2. The quotient of 8, I mentioned 8 first, and 2. So that means 2 came out last. So that's the denominator. That's what normally is. So like the quotient of 12 and 4. How would you write it down? 12 and 4? I said 12 first.
Normally, the bigger number will be used as the numerator.
Right? So 12 divided by 4. It's the same thing as 12 divided by 40. How about when it says the product? What operation signals the word product? That means multiplication, right? So the product of 2 and 3. So how would you write that down? The product of 2 and 3. So 2 times 3, or either way. Now, since it's multiplication, you can write that down as 3 times 2, the same thing.
That's the commutative property of multiplication.
Those are basic phrases. Now, let's go to a little more complex form of phrases that combine more than one operations.
In word expressions.
In most of the phrases which involve more than one operations, normally involve like addition and subtraction at the same time in one phrase, or multiplication and addition, things like that. So the phrase is involved over here is longer, unlike the basic phrases, just 2 words. Here it's like almost like a sentence long, so few words more. So we have an example right there. So 3 more than 8 multiplied by 2. So that's a phrase that's involving more than one operations. So it says here 3 more than 8 multiplied by 2. So what are the operations? So more signals what? Addition, and then what's multiplied by? Of course, it's straightforward. You're multiplying something, right? So that's multiplication and addition. So how would you write that down as a numerical expression? So 3 more than 8 multiplied by 2. It's really clear to you already that 8 is multiplied by 2. So 8 times 2. And 3 more than this. So just add 3, right? Since you know that thing right there, you can reverse also. You can put 3 plus 8 times 2. It will be just the same way. 3 more than 8 multiplied by 2.
That's commutative property of addition.
Well, let's have another example over here of a phrase. 3 less than the product of 8 and negative 2. How would you write that down? What are the signaling word right there that signals an operation? So it says less than, so subtraction right there. This is the product. What does it mean by product? It's multiplication, right? 3 less than the product of 8 and 2. Now you can write that down right there right away. The product of 8 and 2, negative 2. So like that. So 8, the product of 8 and negative 2. So 8 times negative 2. It says here 3 less than the product. So how do you write down? Negative 3 here plus 8. Is that right? It's not right. So what you do? So 3 less. So that means minus 3 here. 3 less than the product of this. So that's how you write that expression, numerical expression. So we have another example right there. So says here 6 more than the quotient of 8 and 5. See the quotient, what operation signals the word quotient as division, right? It's division. Quotient of 8 and 5. And another one right here, it says more than. What operation signals more than? Addition or subtraction? So that's addition, right? So it's here says here 6 more than the quotient. Now, you have to write down the quotient of 8 and 5. How would you write that down? Quotient is that's division, right? That's the answer of division. So the quotient of 8 and 5, so 8 divided by 5. And then it says here 6 more than the quotient than this. So that is plus 6. Right? That's how it's written. Then when you simplify following the rule PEMDAS, parentheses, exponent, multiplication, division, addition, and subtraction. So that's division first. You perform division first before you add, right? That's how it is according to the rule. So you perform this first before you add. Divide first, like divide by 5, then plus 6. Or the other way around. If you put a parenthesis on that one right there, it's clear that we have to do this one first. Except on the condition that if, for example, you have this one right here, so 8 divided by 5 plus 6, and if you have a parenthesis right there, so you have to do the operation inside the parenthesis first, right? Yeah. So, but this one right here, we go back to our topic, 6 more than the quotient of 8 and 5. This, what it is. Right. You can write that down without the parentheses. Okay. Now, when we're talking about variables in algebra, that represents the unknown that needs to be solved or need to be figured out. Normally, is variables are represented by the letter X, Y, or Z. That's Z. That's normally is, or some, or either way you can designate variables in terms of the A, B, or C also, either way. But normally happening over here is we just signify that as X, Y, Z. Let's go to another topic on algebra word expressions. We have this now, writing phrases as algebraic expressions. So how we're gonna write phrases as an algebraic expressions? So we have to signify the letters X, Y, Z or A, B, C as the variable this time, or say a number signifies the unknown number or amount. Let's say a number. When you say a number, that represents a variable. So it can be X or it can be Y or Z. And if it says another variable, so let's say in the same sentence or another sentence next to that says another number. So that means signifies another variable. We have X already. So next variable would be this. That means the second variable. That means you have next one. It will be Y. Or a third variable. You can say third variable. It will become Z. So if you're dealing with 3 unknowns or 3 variables, you can do that. Now let's get some examples on phrases representing multiple operations to be done in just one algebraic expression. So let's say a number multiplied by 2 decreased by 1. So a number, let's say you can signify the variable number as Y or X, doesn't matter. So how would you, let's do that number as, let's put it as signify as X. So a number multiplied by 2 decreased by 1. How are you going to do that? So number multiplied by 2. So you can do that multiplied by 2. Decreased by 1. It can be that. Or what do you think? The other way around? So x multiplied by 2, so that means x multiplied by 2 decreased by 1. What do you think? So this should be the answer right here. So it says the number multiplied by 2 decreased by 1. It didn't say the number multiplied by the quantity 2 less than 1. The quantity didn't mention any quantity. So that's that x times 2. Or it is the same way written as 2x minus 1. Now we have another example over here. This is kind of complex now. The total of 2 times a number and the difference of another number and 5. That's kind of complex word expression to represent an algebraic expression. So how would you, what are the signal operation, a word, what signal word for the operation right here? It says here the total. The total of 2 times the number. So that's that. It says and over here. The difference of another number and 5. So it says here the difference of another number and 5. So that means it says total over here. That means that signals addition, right? What are you adding over here? You adding what? 2 times the number? It says and right there. So that means you're adding this to this, right? Because it says clearly, it says here 2 times the number and the signal word and the difference of another number and 5. So you're adding this to this, right? How are you gonna write that algebraic expressions? Algebraic expression, I should say. So the total says there that signals addition. So you just put addition in the middle right there now. So 2 times the number, how would you write that down? Let x, the first number, right? So let x, the first number, since it says here another number. So you have 2 variables. Y, the second number. All right. Okay, we signified those 2 variables. We have now total. This signifies addition. Now, says here 2 times a number. So we're talking about x over here. That means that's the first number. 2 times the number, that means 2x. Right? And then since you're adding this to this, how are we going to signify this in numerical value or convert as algebraic expression? So the difference of another number and 5. How is that? So another number is y. The difference of, it says, a number is mentioned first. It could be written as y minus 5. Different signals subtraction right there, the difference, right? So of another number and 5, the difference of y and 5, that's what it is. So that's what my 1 y minus 5. So that's this signifies the total. So that means you're adding this to that, right? Now we have another phrase over here. A number shared by 6. How are we going to write that down? So the number is the variable. Let's say x is the variable, is the number. X is the number. So how are you going to write that down? A number shared by 6. What's the key signed word right there that signifies an operation? Shared, right? What does it mean by shared? That means you're sharing something or dividing something, right? So, right, if when you share, that means you're dividing, right? So, like you're sharing your pizza, that means you're dividing your pizza. So that signifies division, right? So how are you going to write that down? So a number shared by 6. So let's write that as, so a number is x shared by 6. So divide by 6. Simple, right? Yeah, that's how it is. Simple. Now, let's have another example. It says the quotient of a number and that number less than the second number. That's kind of complicated, right? So what are the signal words again? If you notice, says the quotient of a number. The quotient, what does it mean by quotient? It signifies what? Division, right? Since quotient is the answer in dividing numbers, right? So the quotient of a number, says here a number and then the second number right there. So you have two numbers. Let's say let x be the first number, right? And since you have the second number, so y is the second number. Okay, so let's go back to that. It's kind of complicated with it, but all right, we can figure that out. So this is easy math, remember. So the quotient of a number and that number less than the second number. So first, we have to write down the division variable here so we could just must clearly identify what are those numbers we're talking about. Okay, so the quotient of a number and that number less than the second number. So the quotient of a number, we're talking about x, so that's put x right there. Talking about this and this, right? So that means this thing right here, this whole thing right here, goes down into as a denominator. So this is the numerator, a number. So now that number, okay, so you go back there, the quotient of a number and that number, what is that number we're talking about here? So the same thing as that number right there. So the same number, right? So the quotient of a number and that number less than the second number. So less than, this is signal word right there. Then what does it mean by that? Subtraction, right? So that means you write down subtraction right there. Now, which number are you going to write here? Left, on the right, which one? X or Y here? Or now we have to understand this one right here again. Try to figure out. So quotient of a number and that number, the same referring to x, that number less than the second number. So number less. So we write x right there. All right. So it's a number less than the second number. What's the second number now? It's y. Right? Is that clear? Simple, right? So let's do it again. Quotient of a number, that's x, first number, and that number, we're talking about x, less than the second number. So that means x less. So y minus x. Got it? That's good. Yeah, it's a little bit tricky and complicated right there, but well, we figure out. Now I'm showing you a table right there. Those keywords signaling addition, subtraction, multiplication, and division. The four basic operations of mathematics we encounter in differentiating, or simplifying algebraic expression. If you notice, those are tabulated right here, see total and all that. Subtraction, decrease right there, double, multiplication, each, times, of, see that, of signifies multiplication, times, and product. And see every, and it signals division, each, out of, or per, percent. You see quotient right here, and share right there also, so that signals division. Right, all you have to do is you got to know all those words that signals the operation involved. So that's the end of our lesson, and I'm leaving you guys a practice where you can do wherever you want to go or whenever you want to. We have 5 expressions right here, and all you have to do is write each phrase as an algebraic expression using x as the first number, using x as the first number and y as the second number. So these are the answers for those questions, those exercises. 1, 2, 3, 4, 5. All right. So you have to do that on those 5 practice exercises. So our next lesson will be lesson 7, factoring. So thank you very much, guys, for your patience following my lecture, and I hope I enhanced your knowledge in any way in this lesson. You may hit the subscribe button below, so help us spread the good thing, learning and encouraging all the kids around the world, and all the people who are willing to learn, and let's give them a second chance to learn algebra in their own way by following my lectures. Thank you very much. Have a great day.
Maraming salamat po sa inyong lahat.